So when we're dividing radicals, we follow a bit of a different process than when we're multiplying them. Multiplying, we just multiply the coefficients, we multiply the radicands, and then we simplify as necessary. When we're dividing, though, we have a condition that must always be met. We can never be left with any roots in the bottoms of fractions. The reason for that goes back to ancient Greece, goes back to long division. It's a discussion to be had for another time. So we need to eliminate those roots in the bottom by maneuvering them and manipulating them so that they move to the top. So in question A, I'm just going to write the question out again. We don't need to worry about the condition that x is greater than or equal to 0. It doesn't impact the math we have to do. So in order to actually eliminate the root from the bottom, we need to take a look at what it is. It is the square root of 3x. And we need to multiply the top and bottom by that, which at this point may not seem obvious why, but give it a minute and it will. So multiplying out the top, we do have two roots. We can multiply them together. We do the square root of 72x cubed. And on the bottom, again, two roots. We can multiply them together into the square root of 9x squared. And at this point, it may seem that we've done nothing, since we still have a root in the bottom. Well, if we take some time here, and we go through the process, we'll see we will be able to eliminate it. The next step to do is to break down both of these roots. So on the top, I'll start breaking down 72. I can divide it by 2 to get 36. Divide by 2 again, I have 18. Divided by 2 again, I have 9. Divided by 3, I have 3. And divided by 3 again. I also have 3 x's. And there's my top broken down. On the bottom, 9 breaks down into 3 times 3. And I also have 2 x's. Next step here is to simplify what we can, pull out what we can. On top I have a pair of 2's, I have a pair of 3's, and I have a pair of x's. On the bottom I have a pair of 3's and a pair of x's. So as you can see now, by doing what I've done on the bottom, I've actually created pairs, and so I can pull out everything on the bottom, and I'll be left with just an expression on the bottom. And anything is fine on the bottom, so long as it doesn't have the root sign. So to simplify this, on top we'll have 2 times 3 times x, which would be 6x, that we can pull out. Leftovers under the root, we have 2x. On the bottom, we had a 3 and an x we could pull out, so we do that. Nothing left under the root sign. And one last step here would be to reduce anything that we can. I cannot reduce with the 2x. It is under the root sign. I have nothing under the root sign to cancel it with on the bottom, so we won't even deal with that. So we look at the 6x and the 3x. Well, 6 and 3 can reduce to a 2 and a 1. X and x will cancel each other out completely. And we are left with 2 root 2x. I don't need to put it over 1. I have nothing left on the bottom. Happy coincidence this time. Moving on, just flip slides to B. I'll lay out the question again. We have 4 root 5n over 3 root 2. Don't need the condition, not necessary. Now, I do have 3 root 2 on the bottom. That does not change anything. I don't need to worry about the 3. I just need to multiply by the root, top and bottom. So root 2. on top here, we'll get 4 root 10n, because I can multiply the 2n with the 5n. On the bottom, we'll have 3 root 4. Break down. The 4 is going to stay. The 10n would be 2 times 5 times n. And the 4 on the bottom would be 2 times 2. Only one meaningful breakdown here. We have the pair of 2's on the bottom. That's the design of this. No pairs on the top. So we can go ahead and combine those back. So we still have 4 root 10n on the top. And 3 times 2 would give us 6 on the bottom. Look to reduce. We can only reduce with the 4 and the 6. They would reduce to a 2 and a 3. So final answer would look like 2 root 10n over 3.